Hello everyone, my name is Manyu Li. I'm an assistant professor at the University of Louisiana Lafayette, and today I want to share with you my systematic literature research on open and equitable education for computational social science. In this presentation, I'll start with an introduction of what computational social science is, and then I'll talk about my study and the study purpose, the method, the results, and at the end I'll share some implications on OER. What is computational social science? Computational social science is the use of computational methods, social science theories, and research methods to analyze human data. For example, researchers may look at Twitter and look at how people tweet. They look at their contents, the people that they follow, and what type of messages they're more likely to retweet, so on and so forth. They also look at online behaviors. For example, people's behaviors towards listening to music, buying products, and they also look at network. And it's not just network within a small group of people, but it could be on a global scale, how people from across the world interact with one another. You may ask then, why do we need computational social scientists? Why couldn't we just hire someone from computer science and have them solve these problems? One main reason is that when analyzing human data, computer scientists' primary concern is to develop programming to make predictions. They solve problems as they arise in the code and are less concerned about the theories behind predictions. On the other hand, social scientists, they are more concerned about the theories, the explanation of human behaviors, and conducting experiments to find causal relations. The reason we need computational social scientists is that we need both. We need both scientists who can code, who can write programming and solve problems in coding, but we also need social science experts who are knowledgeable about theories and explaining human behaviors. In summary, computational social science is increasingly important in social science, and CSS skills are highly demanded in the workforce. Therefore, teaching social science students CSS could significantly increase their competitiveness for future job or graduate school. But how can we teach CSS to social science students? CSS skills usually involve statistics, social science research methods, plus programming. And what I noticed is that there are a lot of research studies already on the pedagogies in these areas. Therefore, I thought we could look into these past studies to inform us about CSS studies or teaching. An additional interest of mine is that how CSS education can be equitable and inclusive, especially given that underrepresented minorities in STEM usually suffer from stereotype threats, exclusion, and not to mention that learning programming could be expensive for some students. So how can we increase the accessibility by providing high quality open education? Therefore, I conducted a systematic literature review, and the research question that I had is, what are some effective evidence-based approaches in teaching social science students statistics or research methods? A systematic literature review search was conducted according to PRISMA guidelines. I used 6 databases, and the keywords that are mainly about pedagogy, teaching, education tool, and also terms such as statistic, data analysis, research methods. And then in my screening process, I limited to only social science students. So the sample has to be social science students. Of course, it will be unrealistic for me to include all my findings in this 10-minute presentation. Therefore, I'm going to highlight some of the main findings that I identify in this systematic literature review. One of the main findings I identified in the process is that many studies discuss the use of technology. These may include data visualization, which is the use of computer methods or technology to allow students to visualize the statistics and visualize the theories. For example, graphing. Other studies highlighted the use of interactive tools and games to help students fight against the anxiety and boredom in learning the subjects. Finally, a small number of studies also mention ways to use technology to assist students with disabilities. The second set of articles concern pedagogy surrounding collaborative learning, and these mean that they're encouraging students to work together to learn the subject, to achieve the learning goals. A large number of studies discuss peer or collaborative learning, peer mentoring, peer assessment, and also collaborative project-based learning. The third set of empirical studies looked at the use of problem-based learning on students' achievements, such as developing creative problem-solving strategies or teaching students critical thinking. Particularly, quite a few studies have suggested that the data are the core of teaching statistic or research methods. So finding the right data for students to do exercises are very important. Many supported that the use of interesting data or even data that students can easily relate to can help students learn statistics. Some even suggested that instructors can invite students to build their own data sets, such as having them create a survey and then collect data to be used in their statistic projects. But others find that creating surveys could be very time consuming and impossible to do in a semester. So they use open data available online or getting social media data. So what do these findings mean for creators and users of computational social science OERs? One implication from the systematic literature review is that there are a lot of studies that really look into the pedagogies for teaching statistics, research methods, or related topics. Therefore, when creating or adapting OER for this new discipline of computational social science, instructors should try to make use of the effective strategies found from past studies in these related fields to design their materials. The second thing to notice is that, as I reported in the findings, there are a lot of studies that look at the use of technology in teaching statistics, research method, or the related fields. Therefore, as we move to teach computational social science as a new subject, new discipline, rather than developing OER texts, maybe we should consider creating, adapting interactive learning tools. For example, LearnR, Shiny app. These are great tools that we can help students visualize the data and also fight against the anxiety that they often experience when they see math or computer programming, and especially for social science students. Finally, given the research findings on collaborative learning and using data sets that help students interact with the data and with each other, computational social science OER creators may consider using data sets that students can easily relate to. In addition, instructors and OER creators may consider adding exercises or prompts that are student-centered and peer learning-centered, such as prompting students to work on problems together. So what are the next steps for open educators? I think that rather than creating OERs based on past experiences, we may want to create OERs based on past empirical studies. So I think the next step for open educators is to take these findings or gather even more findings and to develop evidence-based computational social science OERs. And I'm Manyu Li, and if you have any questions, feel free to email me at manu.li@louisiana.edu.